Okay, so we're going to be looking at Lewis dot structures, how to get familiarized with them, and how to draw them. So essentially, you want to look at the valency as we spoke earlier in regards to every atom prefers a particular valency. Say, for example, carbon likes to have uh, four valence electrons. So, what do I mean by that? Is that let's do the Lewis dot structure, right? So we have C2H6. So we want to do two C's, and then we want to do our H's. A line, a bond, pretty much represents two electrons. We know that we want to fulfill the valency. We don't want to violate the octet. So if you have two carbons, and we talked about our linear structure, which was to, to saturate them, right? So let's go back to the linear structure. All right, so we have completed that. Now you want to turn into a dot. So if I were to represent each one with a dot, it would be each bond corresponds to two dots. So then it'll be as such. And then that way, I get to count the individual dots as electrons, and they're going to be 8. So let's look. All right, so this carbon has 8 individual electrons surrounding it. So does this carbon, the one to the right. So we are good. So this carbon and the other carbon are. All right, so then that would be our Lewis dot structure. So let's go ahead and do the second one. So same idea here. 2 carbons. But now notice how we have 4 hydrogens. So in order to do that, we need to create a double bond. So if we were to do that, we would create a double bond, right? So then that would mean 1, 2, 3, 4, 5, 6. And then this is how you want to think about it. Now we just convert them into dots. And in doing so, we have each bond represents 2. So 1, 2, 3, 4. This is a bond. This is a bond down here. This is a bond down here. And then this would be a bond. So each individual carbon, like this carbon and this carbon, have 8 surrounding. So 1, 2, 3, 4, 5, 6, 7, 8. This counts as the 8 because it has the 2 bonds. So we're not violating any octet. So this is correct. Go back to this. This one's correct. This one's correct. So let's go ahead and do the third one. So same deal here, but do you notice how we are getting less hydrogens? In order to do that, we have to increment the bonds. So this would be the same as doing triple bond. Okay, so in order for you to transfer that triple bond, you just have to represent the number of electrons. So each bond holds 2. So 1, 2, 3, 4, 5, 6. So all I need to do is put 6. 1, 2, 3, 4, 5, 6. Got my bond over here. My bond there, and we are all set. Let's do the 3 carbons. 1, 2, 3. See if you can do this one on your own. And we have 8 hydrogens, so this means a full saturation. If each carbon likes to have 4 valence. So let's do that. It'll be saturation. Each bond represents, each double dot represents 1 bond. So I'm just putting my dots where they would be. And then that would be the Lewis dot representation. 3 at the top, 3 at the bottom, 2 on the side, that would be 8. And that is correct. Let's do the last one down here. So what's different is that we have an O, and remember what you want to think about is you want to kind of put the O off to the side. What do we mean by that? Well, we only have one carbon. Carbon likes to have 8 valence electrons, so the only way to do that is just by putting our surrounding hydrogens. All right. And now we want to have the O and the H off to the side there. So in order to do that, I have my O and I have my H. And we're all set. However, we don't have 8 electrons surrounding that oxygen. So we need to make sure we do that. There. Now it's completely set. No violation of the MCAT rule, and that would be our final. So let's say, for example, that we had this chemical formula as a bonus question. Bonus question. All right, so we want to think about boron. Boron is very special in the periodic table. So if we have this compound, molecular formula of BH3, boron is in column 3A. It's in a special area. So it has 3 valence electrons. So let's do 1, 2, 3, 4, 5, 6. And then our 3 H's. And that would be our Lewis dot structure for boron. It prefers the 3 valence electrons, so that's how it's going to be more stable. I do realize that it does violate the octet, but there are some that will have these exceptions, and I just wanted to throw in boron so you can get familiarized with it in case you see this anywhere.